everybody, welcome back to another video. We're going to be talking about mass points geometry in this video. Mass points geometry is a cool method from physics, rotational equilibrium, and yeah, so what this is where in geometry we study ratios and like it's kind of like a fulcrum or like one of those like balancing things, right? So it's basically a tactic where you assign weights that are basically just labels to points and their distance from the fulcrum or the middle point or whatever, and the lengths and the masses have some relation. So let's talk about it. Let's say this is the fulcrum, like the seesaw. Yeah, that's what it's called. Now this is like that, right? So there's three important points here. We have the middle point, which is the fulcrum kind of end, and then we have the endpoints, right? Now, let's say that this end had a mass of A. We can just assign it A, and we can say that this one is B, alright? And now what mass points tells us, and let's say this one's C, alright? And then let's also label this side length D and this side length E. Now, what does mass points tell us? Oh, and keep in mind that A, B, and C are not point labels. I mean, like they're just masses. So they are labels, but they're not like, you know, when you see a line, you have capital letters. This is not that. So let's talk about the relation between all of these. So the relation is that first of all, the mass of C is equal to A plus B. And then we also have that AD is equal to BE. These two are really important for solving triangles, specifically triangles. I mean, it could be anything, but it's usually triangles that we're dealing with. And I hope you get the basics down. This is basically it. We just assign one mass, and if there is no specification on the side length, we assign side length, and we kind of solve everything from there. So here's some examples. We'll cover two examples. The first example is number 20 on the 2004 AMC 10B. Alright, in triangle ABC, points D and E lie on BC and AC respectively. If AD and BE intersect T such so that AT over DT equals 3 and BT over ET equals 4, what is CB over BD? Alright, here we have a diagram, right? I think they gave it to us, so that's good. Now, it's also multiple choice, so that's also nice. We can use that to our advantage. We can, and typically a giveaway for these kind of, for mass points is ratios, you know, yeah, that's basically it. Ratios, no known side lengths, right? You really know that you need to use mass points then. I'll just keep this there. Alright, so we can assign some mass to anything. Let's say point A has a mass of 1. Let's say, and then also we see that AT over DT equals 3, or AT equals 3 times DT, and we also know that BT over ET equals 4, so BT equals 4 times ET. So what we can do is we can just say that there's no side length specification, so we can just say that dt equals 1, so at equals right, at equals 3, and then we can also say et equals 1 because there is no relation between dt and et. We can just specify that. And if there is, then it just works out, I think. But yeah, you can just specify that. If something doesn't add up later on, then you know that you specify too many things. Like, for example, we can't specify AT to be 7 because we know that we have some relation there. Alright, so now, because ET is 1, BT is 4. Cool. Now it seems impossible, right? How can we find CD over BD out of that? Well, we can use math points. So, first thing we're going to do is we're going to look at D. We know that 1 times 3 equals 1 times the mass of D. So D must be 3. That means that T has a mass of 1 plus 3, which is 4. Actually, I don't want to cover up T. 4. And now because T equals 4, we know that B plus E equals 4. But we don't know E or anything yet. So B plus E equals 4. Alright. And then we also have B 4B equals E. So now we can substitute that in to get 5B equals 4, or B equals 5/4. So now we have B equals, the mass of B is 5/4, right? Cool. Now we can find E as well, right? E is 5/4, or we don't have to find E actually. We can just find C automatically, but we want to find C, by the way, since it'll help us with this line, right? We want to know B, D, and C, so we can find C right away. 3 is 15/3. Wait, I do this right. Yeah, hold on. I think this is 5. No, I think it's right. What did I do? Alright, so let's rewrite that again. We have B plus E equals 4, and then we also have 4B equals E. So 5B equals 4, so B equals 4/5. Sorry, not 5/4. Oops. So then we can find, so now 3 is 15/5, and so that means that C is 15/5 minus 4/5, which is 11/5. We can double check that here. If B is 4/5, then E is 4 is 20/5, so this would be 16/5, and this also checks out. 1 plus 11/5 is 5/5 plus 11/5, which is a 16/5, so we're all good there. Now we can, what is CD over BD, right? Yeah. That seems a little hard since we don't know any side lengths on either of them, right? But we might as well try it out. We might as well write out our mass points formula. We have 4/5 times BD equals 11/5 times CD. So we can multiply by 5 to get 4BD equals 11 CD. And we're looking for CD over BD, so we can just divide by BD and divide by 11 on both sides to get 4/11 equals CD over BD, which is what we're looking for. So our answer is D, 4/11. Typically when you're doing this, you want to go really fast. You just assign things right away, and then you just solve it really fast. It becomes muscle memory at some point. Alright. Now, this next problem is number 24 on the 2019 AMC 8. We could solve this using similar triangles and other stuff like that. That's common, but think it's a good practice to not, we can use mass points. So in triangle ABC, point D divides AC so that AD over DC equals 1/2. Let E be the midpoint of BD, and let F be the point of intersection of line BC and line AE. BC, by that they just mean that like you continue line AE and then you get F, but you can look at the diagram. Given that the area of triangle ABC is 360, what's the area of triangle EBF? Ooh, areas. That's nice. We can only find some masses, right? So how can we do it with mass points? Well, I'll show you. So, remember, we can assign anything a mass, right? I'd say, we'll first assign the side length. So AD over DC equals 1/2. We don't have any side length specifications like in the last problem. We only have an area, so we can let AD equal 1. Oops. AD equals 1 and DC equals 2. We can also specify that the mass of A times 1 equals, yeah, so I would specify A to be 1, but then C would be 1/4 or 1/2, and I don't really like that. So I'd rather let C have a mass of 1. Typically, a mass of 1 is a good way to start with, right? You wanna setting a mass to 1 is a good way to like begin problem solving with mass points, but later on you might head to 6 or something. But I think 1's a good way to go for now. Before we proceed, and then A's too. Before we proceed, let's underline some important stuff here, because in these high school and middle school competitions, typically the problems are a bit like there's a lot of information in it, and sometimes a good tactic is to look back in the information that you have not used. So we want to know what to look at. We know this. E is a midpoint. Area. Yeah, we're looking for that. So yeah. I think that E be a midpoint. That's a really important thing that we need to know. So yeah, cool. Let's do it. Let's say that, yeah, so now let's specify that, right? I'll use blue since I used blue in the last one. So this is X, just for now. X might be a different variable later on. Let's just say that X is that for now. Alright, so, oh yeah, we can also say that D is 2 plus 1, which is 3. And now we can say that, 3x equals bx. So b equals 3. Now we kind of have to write that out, but typically later on, that's gonna just be muscle memory. That like if two sides are the same, then the masses are the same or whatever. So yeah. Now we have E equals 6, so F equals 4, and that checks out this way too. We don't have much more to do. But yeah, we've assigned everything, so now we can start looking at the problem. We have weird triangles. We don't have any right triangles based on this diagram, at least. So we better find a way to solve it. I'm just gonna go ahead and say it. Something good to know is that the altitude of ABC is the same altitude as triangle AFC and AFB. So now that's good to know, right? Cool. So yeah, now we can continue from there. Alright. God. Yeah, cool. So now we know that. Now how can that help us? Well, we can also look at the bases, right? So we know that the base of triangle BEF or EBF or whatever is the same as the base as ABF, right? So we should probably find some relation between EF and AE because notice that the ratio of AE to EF is the same as the ratio, the ratio of EF to AF is the same as the ratio of the height of ABF to the height of EBF, which will be helpful for finding the area. And because the height of ABF is the same as triangle ABC, that'll also help. So a good thing to write down is that, let's say lowercase b is the base of triangle ABC, and lowercase h is the height of triangle ABC. So now we have BH equals 720, right? So now we can look here and we can look at line AEF, right? We have their masses, so we can find some relation between the lengths EF and AE. We know that AE is equal, I think, to 2EF. Alright, from mass points. Good old. So now that means that we have that means that EF, oops, what was that? Yeah, sorry, 3EF equals AF. Alright, so now that means, let's specify that capital B, not the same as this capital B, by the way. It'll be different. Let's say that capital B, the capital B is the base of BEF, and capital H is the height of BEF. So BH over 2 is what we're looking for, right? Now we can put it in terms of lowercase b and lowercase h, right? That'll be helpful, and then we can find this out. So now look at this. We know the relation between EF and AF, but notice that EF over AF is the same as that ratio is the same as the ratio of the heights of BEF and BAF. Alright? So now that means, and because the height of BAF is the same as the height of ABC, which is lowercase h, that means that that is equal to h over h. And since we know that this is 1/3, this is equal to 1/3, right? So now that means that capital H is equal to h over 3. So we can substitute that in to get b lowercase h over 6. Now we just need to find b, capital B. To find that, we can look at the bases, this line. So far we were looking at this line, by the way. Look at the bases, alright? Let's say this, so yeah, actually we don't have to do that. So notice that this BF is really just capital B, right? So notice that 3B, based on mass points, is equal to 1 times FC. And notice that, notice that. And so now we can also notice that the base of triangle ABC is BC, right? So what you can see here is that FC is 3 times B. So this is 3B. So the total is 4b. That means that the whole base of ABC, which is b, or lowercase b, is equal to 4 times capital B. So capital B equals lowercase b over 4. So this is equal to BH over 4, or over 4 times 6, which is 24. Cool. Now we have the area of EBF in terms of BH. That's equal to 720 over 24, which is the answer. But we need to simplify it. If we simplify it, we get 360 over 12, which is 60 over 2, which is 30. Our answer is B. Oops. Alright. Yeah. So, really all we did all together was specify some mass or length and then find the rest and then use ratios and areas and stuff like that. We want to find something in terms of what we know. So basically, a good key point strategy here, problem solving tip, is to find something that you don't know in terms of something that you do know. Alright? Cool. Thanks for watching. Watch more of our videos and you'll learn something. Hopefully you learned something in this video. Alright. See you guys next time. Bye-bye.